may remember from our last video that where we choose to live matters. At Emerson Green, we take this commitment to the environment very seriously by baking in the ability to use 60% less energy into every single one of our smart homes for today and tomorrow. Now you may be asking yourself, how do you know how much energy you're consuming? Well, at Emerson Green, we utilize a home energy rating system, otherwise known as HERS, to evaluate the performance of every single home that we build. A typical Emerson Green home rates between 35 and 45, as compared to a normal code-conforming home, which would be 100. So the amount of energy a home uses is a function of three elements: air infiltration, insulation, and the performance of the doors and windows.
Hi, my name is Peter Osinski. I'm the newest homeowner here at Emerson Green, and I'm here with Sean Ford today to learn a little bit more about the construction technology used in these awesome homes. So Sean, tell me about the way that these homes are insulated, the choice of insulation, both exterior and interior, and how that affects the energy efficiency of the homes.
Well, first of all, Peter, we have to look at how the homes are framed. What we use is an advanced framing system on all our homes.
Mm-hmm.
So what advanced framing is it's trying to use less framing material so that we can get more insulation in the house.
Gotcha.
And there's an example of that right behind you. In this stud pocket, in the past, these would all be filled with framing material.
Yeah.
To pick up the nailers for the drywall on each side. Now we leave it wide open so it can be filled with insulation.
Oh,
Right.
Does that so does that help reduce the thermal bridging from
That,
or?
that doesn't as much help the thermal bridging, but that in addition with all the studs being 2 foot on center instead of 16 on center, reduces the amount of lumber in the house.
Ah, okay.
The thermal bridging part is what this insulation is here. This is all an 1.5 inches of rigid insulation, and that's applied to the zip wall sheathing that's on the outside.
Okay.
Any of your framing material that's directly in contact with the outside wall, you'll get cold transfer from the temperatures outside in the house.
Once you have the exterior insulated, what do you do to fill the interior cavities and the attic?
It's an open cell spray foam, and what makes spray foam different than any other insulation, whether it be fiberglass, any fiberglass bat or even blown in fiberglass, is it eliminates the drafts in the house. It stops all the drafts.
Okay.
So your typical other insulations, they have a good R value, resistance for heat, but they don't eliminate drafts at all, and they're very difficult to use in some of these spaces around these odd shaped joists up in here.
Yep.
You can never get it in there right.
Yeah.
So it's covering the space 100%. But with the spray foam, which expands into the wall, it gets into every nook and cranny and it eliminates all the drafts in the house.
So that explains that's one thing that we've noticed. I mean, we've been in our new home for about a month now, and you're right. That house just feels so tight.
Yeah.
And then, do you do anything in the attic?
And then the attics, well, we use different insulations in different places because it performs better in different aspects of the house, right? So actually, in the basement on the blockers, we'll use a closed cell spray foam. Up here, we'll use an open cell. Where we have enough room to get the R value in this wall. When we're done with this wall, it'll be at an R30 between the zip wall on the outside and the spray foam on the inside.
Okay.
Which far exceeds the code.
Yeah.
And then in the attic, we go to an R50 with 16 inches of cellulose.
Oh wow.
So the attics get spray foamed as well. If there's any penetration in the deck of the drywall, we spray foam over the top of that.
Yep.
As a draft barrier, and then 16 inches of cellulose on top of that.
Nice. We've noticed that these houses seem to be incredibly well insulated because we barely have to run our heat to keep our house nice and warm.
Yep. and a big.
So Sean, since these homes are so well insulated and so tight, what measures do you take to control air quality and to make sure that there's always an appropriate amount of fresh air in the home?
So what we use, Pete, is a HRV system, it's a heat recovery system, and that's what this is right here, this box right here. So
Okay.
what happens inside this box is we have fresh air coming in from the outside,
Yep.
and it's crossing air from the house that's being exhausted out. And in that crossing, what happens in this box is the air that's coming in from outside, the temperature is being tempered by the air that's being pulled out of the house that's already been heated.
Okay.
So we're not bringing in direct, cold air, the outside temperature to the house,
Gotcha.
okay? And that doesn't come into a vent in any one place. It goes directly into the air handler. So it's distributed throughout the house through the air handling system. So everywhere you have a register for your heat, you're also getting fresh air at the same time.
I see.
And that air is being, and as air is being pulled out, it's helping with the oxygen level in the house. If you're cooking and you have some, any kind of cooking smells, they don't linger in the house. All the air that's running through the system is being filtered 3 times. And these houses coast, once they get to temperature, they coast and they use very little energy at that point.
Okay.
So there's no need to be opening windows and doors all the time.
Our system, it definitely seems to run best when we just set it and forget it,
That's the idea.
and the house just stays comfortable 24/7.
Again, when you turn your thermostat down, and then you come home and you want to turn it back up, it actually uses more energy to heat the house back up, because you're trying to heat up all the contents of the house, the floors, the walls, everything, you're trying to bring up to that temperature. And it's not efficient at all. You're actually using more energy doing that. So the best bet is just to set it and forget it. Let the house just run at one temperature, and then you're always comfortable.
Okay. So Sean, when you have penetrations in the building envelope, such as windows, doors, maybe other things like dryer vents, do you take any special steps to mitigate any potential negative impacts of those penetrations?
We take special care in that with our window installation, and it all starts with the framers when they prep for the setting a window. They actually put cedar siding on the sill, which creates a 5-degree pitch on the sill that pitches any kind of water out.
Gotcha.
That's just the base, and then it gets 3M tape or bitumen tape that we use. Then once the window is set, it's completely siliconed in, and then zip tape is applied all around the edges.
Okay.
And that eliminates any air infiltration. So that's what keeps the envelope intact.
I see.
So we use that on the windows and doors. If we have anything else like electrical outlets outside, a lot of that is mitigated with spray foam. By using the spray foam in all the walls, we're not going to get a draft on those. We're going to maintain the R value of the wall.
So that explains, the house I used to live in, I could always feel air, especially in the winter, cold air coming in through the outlets. In this home, there's none of that. There's no air.
These systems and our attention to detail result in an annual savings of $4,000. If you multiply that by a 15-year mortgage, that's $60,000. I think that's a big deal. If you want to learn more about our energy-efficient homes, visit emersongreen.com. Or even better, come by and visit us at 88B Grant Road.